Going on now to the last part of Chapter 2. Now, again, if you could open up your booklets so you can have the left side blank page open, it's a good place to take some notes. But if you'd like to do it on this side too, I guess that'll be okay. Now, what we're going to do is look at percent and mixture word problems. So as we look at percent, I think the key is to set it up as an equation. Now often when they're written like this, you can just directly transfer this information into algebra or arithmetic in some cases. So let's look at letter A. 5%. Well, we convert that to a decimal. Now the word of in a sentence like this actually implies multiplication. So 5% of, and we're going to indicate that through a parenthesis, 300 is, we know at this time, is an equal sign. What number? The letter N, or you can use X. So we'll get back to how to solve that in a minute, or a few minutes. All right, now this one. All right, 207 is 90% of what number? So again, we're looking at putting the N in different places, but just reading it right from the statement into algebra. 15 is 1% of what number? What percent, now here we're going to put a P, of, now we don't have to put a parenthesis here, but we will, is 420. So for letter A, this is straightforward. Just multiply this. And I've put it in my calculator already, and this gives us a 15. Now here we're going to do division because 0.90 is the numerical coefficient of n. So we divide both sides by 0.90, or just 0.9 would be good. So we get n, these just cancel out here, and we divide this by 0.90 and we get n equals 230. Now here, very similar, we're going to divide both sides by 0.1. And we get n equals, and we get then, when we divide 15 by 0.01, 1500. And for letter D, again, we want to isolate the P, so we'll divide both sides by 350. And we get then P equals 1.2. Now here they're asking for percent. We use the letter P, but 1.2 isn't a percent. To convert this to a percent, you may recall, you move the decimal places, you move the decimal 2 places to the right, and then add a percent sign. So the answer to letter D would be 120%. In number 2A, these will all be discount or markup problems. and they want us to round to the nearest cent. Okay, going out of business. Sale advertised a 75% discount on all merchandise. Find the discount and the sale price of an item originally priced at $130. So some of these you can do by arithmetic, but if we wanted to do it algebraically, we could say 75% of the original price gives you the, actually it's yes, the letter D would be better. This is the discount. Now, once you did this multiplication, you could subtract it from the 130, or if you wanted to figure out what the sales price was, you can just say you're paying 25% of this since you're getting a 75% discount. So if you wanted to figure that out, you could go it this way, 0.25 now times 130. Now this would be the sales price. If you're getting a 75% discount, then you're only paying 25% of the original price. So your discount of the original price, 75%, is this much money. That would be a good deal if you needed the item. And then the actual sales price, we could take this, subtract it from 130, would give you this. Or another way to look at it, you're paying 25% of the original price if you're getting a 75% discount. And this is what you pay at the register. Now in example B, you go out and have a dinner that costs this much, not including the tax. But a general pattern is to leave a 15% tip added to the cost. What would that be? Find the total cost. Well, what will you pay in percent of this original price? And the answer is you're going to pay 100%, that would be all of this, plus 15%. So if we say 100, 15%, I've just added the percentages together, the whole meal, which is the 100%, and then the 15% of this, times this, that will be the final price, or what you pay at the register, excluding the tax. So 115% of the original price includes 100% of the original price plus the 15% tip. I just put it together. So P here would then equal $167.74. Now for these next few, we're going to look at percent of increase and percent of decrease. So as you read the problem, are you looking for increase or decrease? Now the recipe is similar, and I'll go over that. The number of minutes on a cell phone bill went from 112, or 1200 I should say, to 1600. So you can see that's increasing, so that would be percent of increase. So what you do, you now have the amount of increase. Now the recipe is always this: put the amount of increase or decrease, works the same way, over the original amount. And that will be your percent of increase here. Here we can just cancel these out and we get 1/3. Now 1/3 is 33 and 1/3%, but they want us to round to the nearest whole percent. So that would end up being 33% increase. So here in 2004, they had this many students enroll, but a year later, there were fewer students enrolled. So this was a decrease. Again, we subtract the numbers. We find the difference between them is 1,300. Now we put the 1,300 over the original amount. It's always over the original amount. Put that in your calculator and you get this. They want us to round to the nearest whole percent. So we look at the thousandths position here. This is a 6. So we'll drop the 6 and add a 1 to the 4 to make this 15%. And that would be percent of decrease. Now here, you can almost guess that you're going to get one like this on your test. Find the original price of a pair of boots. If the sales price is $120 after a 20% discount. Now often what students will do will take 20% of this, get a number, add it to that. It's close, but it's incorrect. You cannot do it that way. So let's do a little bit of algebra here. We're going to say the original price is going to be N. And somehow we want to get that N to be 120. Now we know that's not an equation yet because this is not equal. This is the original price. This is what you pay with a 20% discount. So if you're getting a 20% discount, what percentage does this reflect of the original price? Well, if it's 20% discount, you're getting an 80% is what you're paying. This represents 80%. So this is the original price. If I take 80% of the original price, that's what this is. This is the way these must be figured out. If you do it the other way, it gets close, but it's not the answer. So 20% of 100%, if you take that, is 80%. So this is 80% of the original price. And that's what I have here. 80% of the original price is 120. So you divide both sides by 80, 0.80, and you get N equals 150. Now our textbook is suggesting that you use a chart for something like this, but let's read it carefully. How much pure acid should be mixed with 4 gallons of 30% acid in order to get an 80% acid solution? Now they do in your math lab ask you to use charts, so we'll use this one. How much pure acid? Well, we don't know. So we can call that X. What is the strength of pure acid? It's 100%. So how much acid would you have then if you multiply the number of gallons by 100? Well, you have 100x. Now, how many 30% acid solution do you have? Well, you have 4 gallons. And what's the strength of that? Well, it's 30%. So how much will you have when you finish? Of this, you'll have 4 times 30. Now, you want to end up with 80%. Now, how many gallons will you have of the 80%? Well, you're going to have X amount plus 4. And we put that in a parenthesis to indicate it's like a sum. Now, what will the strength of 80% be? And how much will you have when you finish? Well, you're going to have 80 times X plus 4. And there basically is our equation. 100x, this is our pure acid number of gallons, plus 4 times 30, our 30%, to equal 80. Now, if you had made this percentage, you could put a dot there, a dot there, a dot there, then you would have multiplied everything by 100 to get this. There'd have been a dot in there. Okay, so clearing parentheses, distributing, I now will subtract 80x from both sides, and I get 20x. Just transpose that, subtract 120 from both sides, and I get 200. Now I divide both sides by the coefficient. I get x equals 10. I will need 10 gallons of pure acid mixed with 4 gallons of 30% acid to get, altogether I'm going to end up with 14 gallons of 80%. And by using algebra, we solve that nicely. This is why you need algebra to do chemistry, by the way, if you are moving in that direction. Now in topic 2.7, we're doing some more word problems, but here we're going to feature distance equals rate times time. This is the distance formula. So when we have things like this, this is the formula we're using, and you can see I have it here as well. How long will it take a car traveling at 60 miles per hour to overtake an activity bus traveling at 45 miles per hour if the activity bus left 2 hours before the car? Now, they do use a chart, so we'll follow along with this as well. So, what is the rate of the car? Well, it's 60. What is the rate of the activity bus? 45. Now, they want to know how long will it take for the car. So that's time, isn't it? So we'll say that for this, it's time. We don't know how much time. And for the activity bus now, it has this amount of time as well, plus the 2 hours it went ahead of the car. Now, what do we know about the distance? Well, theoretically, we have one going this far and the other going that same distance. So distances are the same. Well, what is distance? Well, distance is rate times time. So this is going to be 60t, and this is going to be 45t plus 2. Now we're going to set it up to each other. 60t equals 45t plus 90. I'm just going to distribute that. Now I subtract 45 from both sides, and I get 15t equals 90. Now you know what I'm going to ask. How do I solve for t? Well, I divide both sides by the 15, the numerical coefficient of the variable. And I get t equals 6 hours. So what are they asking? How long will it take the car to overtake the activity bus? Well, it would be 6 hours. How do we know? Well, we solved it through algebra. Now, a number of students have been working ahead, so in lab I've sat with many students going over things like this, but here it is in our lecture session. A collection of dimes, quarters, and nickels are emptied from a drink machine. There were two. Our book had an error there, but I've corrected it. There were 2 times as many dimes as quarters. And there were 10 less nickels than there were quarters. If the total value of the coins was this, find the number of quarters, dimes, and nickels. Now, if I were setting this up, I'd do it a little differently, but since the book did it this way, we could do it. But I would say, what would the number of quarters be? This is the thing we don't have any reference to up here. I would have used the letter Q, but X is fine. Now, there were 2 times as many dimes as quarters. So how many dimes did you have? Well, 2Q, or 2X. And there were 10 less nickels than there were quarters. So again, Q is the number of quarters. We're using X. X minus 10. Now, how many coins did you have altogether? Well, you had X. That was the number of quarters. Plus these, which was 2X. Plus these that we'd have to put in parentheses, X minus 10. That would be the numbers, but we're not that interested in the numbers. What we're interested in is its total value. So, how do we figure this out? Well, notice we're giving it as cents here. So what is the value of a quarter? What's the value of a dime? And what is the value of a nickel? Now, If we have this many quarters, this is like a number, 5, 10, 15, whatever, we don't know, and each are worth 25 cents, what is our total value? And this is what some of you are having a problem with. It would be 0.25x. That's the value of all the quarters. This is the number of quarters. This is what each one is worth. Now for this, it's going to be 0.10 times 2x. Because this is the number of dimes. And for nickels, 0.05 times your number of nickels, which is x minus 10. Now this must be in parentheses. This one, yeah, I think so too. Now, what is the total value of all of this? Well, here's our equation. 0.25x plus 0.10 times 2x plus 0.05 x minus 10, and we say that equals our total, 19.50. Now, from an earlier technique, we would suggest you get rid of your decimals by multiplying each term. This is a term, this is a term, this is a term, this is a term, by 100, moving our decimal places over. And now we don't have to worry about decimal places anymore. All right, we multiply through. To save time, we distributed. We collected like terms. This is 50. We added 50 to both sides. We divide both sides by 50. We get quarters as 40. So how many quarters? 40. Now, how many dimes? Well, 2 times 40 is 80. And how many nickels? Well, 40 minus 10 is 30. Now, in example 3, we're going to go back to what we had mentioned in a previous lesson. Here we're receiving an $80,000 bonus. We want to divide that 80,000 into 2 parts. And we said a way to do it was to say X will be part of that 80,000, and the other part would be 80,000 minus X. That was a way we had mentioned earlier to divide a known amount into 2 unknown parts, just for the algebra to work. Now, they earned interest, so the interest formula is interest equals principal times the rate times the time. So this was in just 1 year, so T is 1, so we can sort of forget about it for now. Now the total interest was this, but it's in 2 parts. So, how much did he invest in the 10%? Well, we don't know that, but that's what they want. So I'm going to say that this is what the X part of that principal of the 80,000. And we're going to say then this is 10%. Let's just put it here. And this one will be the 8%. Here we go. So this is going to be 80,000 minus X. Now the rate, of course, at the 10% was 10%. And for the 8%, 8%. And the time is just 1 year. So how much interest would you get from this investment? Well, it would be this times this. And for this interest would be this times this. So it's going to be this. Let me write it out here. And you can write this out too. Remember to put that in parentheses. Plus, because this is a certain amount of money. And then 10%. X is going to yield a combination of that interest from all of that 80,000. Now here I have to add 2 decimal places. You might say, why? Because I'm going to multiply everything by 100, so I get rid of my decimal places. So let's work that out. So 8 times this is 640,000 minus 8x plus 10x equals 730,000. I combine like terms, I get 2x. I subtract this from both sides, I get 90,000. I divide both sides by 2. I get x equals 45,000. Now notice that since x was our 10%, this is what they're asking. How much did Jeff invest at 10%? We have it right there. Now if we would have switched these numbers around, our x here would have been 35,000. Then we would have had to subtract that from the 80,000 to get the 45,000. That's how it's shown in our booklet. I did it the other way. So we got the answer right away. Now, what I'd like everyone to do over on the left side of your booklet is to do this background information I'm going to do with you, and that is how to graph inequalities on a number line. This is going to be one of the big things for topic 2.8. Now, these are your inequality signs. You may remember this from chapter 1. This is less than or equal to. This is greater than or equal to. So we want to graph this. So here's a number line, and on all of these it's just going to be 2. Now I didn't have it all finished, so we could do some of it together. Now, what does this say? It says x is less than 2. Is 2 in this system of numbers? If it's less than 2, then 2 isn't. So we're going to use a parenthesis, facing left, darken this arrow and line, and there is the graph of x is less than 2. This is going to be a useful reference tool. Now, as we read this next one, x is less than or equal to 2. Now, 2 is in the system. It's in the set. So we indicate that where it's not in the system with a parenthesis. When it's in the system, we use a bracket. And that's the major difference. And otherwise, it's the same. So x is less than or equal to. The bracket indicates that the 2 is a member of that set. All right, more background. X is greater than 2. Is 2 in the set? No. but it's greater. It's going this way. So we use a parenthesis going this way, and then darken the arrow. X is greater or equal to 2. Is 2 in the set? And the answer is yes. So we use a bracket, again, facing right, and like so. Now, another thing we often use is what is called interval notation. Interval notation comes, in a sense, right from the graph and looks like this. Now, we want to write this graph or this expression in interval notation. So we go over here, and we usually go from left to right. Where is this coming from here? Well, it's coming from negative infinity. And whenever we use infinity, we always use a parenthesis. And then we put a comma, and it's going up to a 2. But 2 is not included. So right from the graph, we use the parenthesis. Now in this example, again, this part is similar. It's the same, actually. It's coming from negative infinity, and it's going up to 2, but now 2 is included, so we use a bracket. Interval notation, graphing this inequality expression. Now here, very similar. Notice you're going from left to right from the graph. So it's coming from 2, but 2's not included. That's why we have a parenthesis. And it's going to positive infinity now. And this one, very similar, bracket now because it is included. And it goes to positive infinity. Infinity always has a parenthesis. Now, knowing this and studying it and then using it as we have various examples, this is going to be very helpful for your mastery. All right, let's do this one. So here, let's just put numbers down. This is going to be a -5. This is going to be a 7. This is going to be a -3/2. And when you make fractions, always make a horizontal bar there. And this will be a -2/5. Now here, this one's a little tricky. I often suggest when the letter is on the right that you set it up where it's M. Now notice the point is toward the M, so we just copy it this way. And like so. So now a hint, and this is by a colleague, mentioned that which direction will our line go? Well, it follows the point of our inequality symbol. Here, you might think it goes this way, but it's sort of backwards. So it's actually going to go this way, and this one goes this way. Okay, we'll give you a moment to put these in. Okay, so again, because of the equal sign, we need a bracket, and it's greater than, so it goes this way. Just a parenthesis because of the inequality, and then going to the left. Here, putting it in its correct form, or a more understandable form, we see the arrow goes this way, and it's also an equal sign, so a bracket, and then this one. Now, we'll pause. I'd like you to put these in interval notation. Take it right from the graph. Right from the graph, bracket, -5, positive infinity. It's coming from negative infinity. Don't forget to put the negative sign there. And again, infinity always has a parenthesis, comma, 7, parenthesis. And again, putting it in this form, it's coming from negative infinity, comma, negative 3 halves, bracket, right from the graph. And again, right from the graph, parenthesis, negative 2/5, comma, infinity, parenthesis. Now, when we solve inequalities, we use mostly all the same techniques of solving equations. That is, we can use the transposition. Here we have x is less than or equal. Transpose the 7. It now becomes a -7 on this side. So this will be 5. And again, the number we're interested in is 5. This is less than or equal. And we use a bracket going like so. And putting that in interval notation, negative infinity up to 5, bracket. Again, transpose, x is greater than, on this side it becomes a plus 10, and that gives us a 7. So 7, and again, it's only greater than, so it's a parenthesis, and an interval notation, parenthesis 7, positive infinity. Now here, an interesting thing occurs. If I move the negative 4z to this side, this will remain a negative z. And I move the plus 1 to this side, this becomes a negative 3. But now, in order to get this to be a positive z, I have to divide this by a -1. And that's a problem. And the problem is, and I'll give you the background, so this is so important. If I have a 2 that is less than 4, you'd say, well, that's true. 2 is less than 4. And if I multiply that 2 by a 2, and this by a 2, I get 4 is less than 8. And that is true. But if I were to multiply this side by a -2 and this side by a -2, this would be a -8, I'm sorry, a -4 and a -8. Now, is -4 less than -8? And you might say, no, that's not true. So because of this, whenever we multiply or divide by a negative to keep the statement true, we have to reverse the direction of our inequality sign. So right now, it was going that way, so we have to reverse it. So now our answer here would be z is greater than 3, because this became a positive 3 on this side and a positive z on this side. So that's the one crucial difference when you're solving inequalities, that if you have to multiply or divide by a negative to keep the statement true, you must reverse the direction of the sign. Okay? Now, did I do that? 3. Z is, I wrote it this way now. Okay, so this is going to be 3, parenthesis here, this way. And interval notation, parenthesis 3, comma, infinity. Now let's clear this up so we don't get too distracted. Now in this one, there is a workaround. I could have done this one this way too. And that's how I would do it. So to keep my x's positive, I'm going to move this to this side, where it becomes a positive 3x. So this leaves me with an x now, positive on this side. And I'm going to subtract 18, or transpose that, and I get a 6. So, much easier if you keep your variable positive. And if I brought it to this side, let's do this one too. This would be a 1z here. And I'm going to transpose that negative 2, and that was 3. So we did it the other way, just to show you. And now this is a way, now I don't have to worry about reversing the sign. This is what I had. Z was greater than 3. Here, 6 is less than, or I should say x is less than or equal to 6. So there's our 6. And we're going to use a bracket. Because of the equal sign, 6 is included. And then when we put it in interval notation, it's from negative infinity, that's what's out here, up to 6, bracket. Okay. Now remember, I do have a longer version of this, but in letter E, we're now going to multiply each term by the lowest common denominator. So on this side, the 3's cancel out, and I get then a negative 21 is, 24 I should say, is greater than or equal to x. And I would write that the other way to graph it and use interval notation. Here I'm dividing by the coefficient of x, and this will just be x is that, whatever it happens to be. Here I'm dividing both sides, or multiplying both sides by 8, and I just get 0 is less than y. Again, I would write that the other way. Now here, this one's a little tricky, because in order to get a positive z, I have to multiply this by its reciprocal, which is a negative 5/3. Flip it over, same sign. And when I do so, I have to reverse the direction of that sign. And then here, these are just other examples in which you, in this case, I would multiply both sides by 21 to get rid of my fractions. Here the 21's cancel out. This will be 1. This will be 3. So this will be 3. And I don't have to worry about it. Now, these are compound inequalities, so we'll spend a little time on this. Here the t is already isolated. So when we go to graph it, we have a negative 5 there. We have a 0 there. Now this sign will be a parenthesis. This sign will be a bracket. And we just fill it in. And interval notation, right from the graph, parenthesis, negative 5, comma, 0, bracket. Now for something like this, we need to isolate the x. So we're going to divide this by 2, this by 2, and this by 2. So we get a negative 6 is less than or equal to x is less than negative 4. So when you have your variable in the middle, these are compound inequalities, you have to eventually isolate the x. And we use the same techniques, but to each part of it. So this is a negative 6. This is a negative 4. Here we're going to use a bracket. Here we're going to use a parenthesis. An interval notation right from the graph. Bracket, negative 6, negative 4, parenthesis. Now, in letter C, we're going to add 9 to everything. And we can use that old technique. So this is a 12 is less than or equal to 4x. And then this is a 16. Now to get rid of the 4, we just divide it out. So we get 3 is less than or equal to x is less than or equal to 4. And to graph, we have a 3, a 4. These will be brackets. And interval notation right from the graph. And again, if you watch this again, that may be useful. Again, you want to know the strategy of what goes on here. So 8 more than twice a number is less than negative 12. And I think you can solve that. Transpose, divide by 2, and those are your answers. One side of a triangle. In our last example, a picture of a triangle may be in order. We're saying that one side is 6 times longer than another. So this will be the short side in a sense. This is 6 times longer. And the third side is 8 inches long. Find the maximum lengths of the other two sides if the perimeter can be no more than 106. So that would have to be less than or equal to 106. And the answers are below. Okay, well, again, for those that are ready, if you have the mastery points, you can test on Wednesday or take the self-assessment Wednesday, but everyone will be testing on Chapter 2 a week from Wednesday. And next Monday, our lecture will start Chapter 3. We're not going to advance anything. We're just like 1 week ahead. Hopefully, many of you are advancing and hopefully can finish early. All right, well, good luck to everybody.